Welcome back. This is Geometry, Unit 2, Section 2-2. The title is Biconditionals. This is video 1 of 4. So we just learned about conditionals. You have an if-then statement. That's a conditional. If that statement's true and you can write that statement's converse and that statement is also true, you can write what's called a biconditional. And a biconditional is like this all-encompassing one fact that just holds truth. All of the definitions that we cover from here on out can also be written in biconditionals. Same with any of your classes. Any vocabulary term that you've seen inside of one of your courses can be written as a biconditional. So let's look at a conditional. Let's check its truth value. Let's see if its converse is also true, and if it is, let's practice writing a biconditional. Now the key phrase when we write a biconditional is an if and only if statement. So instead of saying if this then this, we're going to say this if and only if this. We're going to drop the if, we're going to drop the then, and we're going to place an if and only if between the two ideas, the hypothesis and conclusion. Okay, so let's look at the conditional that I have written here. If an angle is acute, then its measure is between 0 and 90 degrees. So we obviously have a hypothesis here. If the angle is acute, it's a hypothesis. Here's the conclusion. Its measure is between 0 and 90. And that's true. It's impossible to give an acute angle that is not between 0 and 90 degrees. So the truth value of that statement is true. Let's write its converse. So if an angle measures between 0 degrees and 90 degrees, then the angle is acute. So the truth value of that statement is also true. It's impossible to have an angle that measures between 0 and 90 degrees and it not be an acute angle. So therefore that statement's true. So if we come across a scenario where the original conditional is true and its converse is true, what we've just developed is the definition for this term acute angle. So we can now write this as a biconditional. Now it doesn't matter which one of these parts, whether you want to write the hypothesis first or the conclusion first, it's completely irrelevant. You just know that you're separating both of these ideas with an if and only if. So we're not starting our new statement with if. We're not throwing a then in the middle of our new statement. We're combining these two underlined phrases with an if and only if. So here's one possible way to write this. An angle is acute if and only if its measure is between 0 and 90 degrees. Its measure is between 0 and 90 degrees. Now if I wanted to, as long as I have the if and only if in the center, I can switch around the order. So I could say its measure is between 0 and 90 degrees if and only if it's an acute angle. So it doesn't matter hypothesis or conclusion coming first in the biconditional. What does matter though is we can write it when a conditional is true and its converse is true. We drop the if and then statements and we place inside of it an if and only if.